Okay, this is page 245, and this page is going to show you how to find the prime factors of a number using a ladder diagram. This is the same idea as using a factor tree. It's just a different tool, and you might prefer it. We'll find out. Alright, so read it with me. Using a ladder diagram. A ladder diagram is another way to find the prime factorization of a number. The directions read, use a ladder diagram to find the prime factorization of 132. So if we had nothing written here, let's pretend we had just a blank spot for our work. We would start by just writing 132, and we do kind of an upside down division symbol. What we're going to do here is we're going to factor out the prime numbers, prime factorization, 3 to a together. It says write 132 in the top step of the ladder. Choose a prime factor of 132 to write next to the step with 132. Choose 2. So they're just telling us to choose 2. So now what we're going to do right here, it says divide 132 by 2 and write the quotient 66 in the next step of the ladder. I'm actually going to go ahead and clear all this because now you understand how to set it up. They put the 2 here and they put the 66 here. I want to point something out to you about 2 and 166. What happened here was we took our number given to us in the problem, 132, we divided by 2, that's this number, and we got 66, that's this number. Now we're just going to go ahead and keep going. Now choose a prime factor of 66. Write the prime factor next to the step with 66. I'm going to choose 2 again. And how many times does 2 go into 66? It's 33. So our answer is going to be in these, like this section, and these are going to be our prime factors. We're on C now. It says keep choosing prime factors, dividing and adding to the ladder until you get a quotient of 1. So we keep going until we get a quotient of 1. So what goes into 33? I know 2 doesn't, but 3 does, and it goes in 11 times. Now this is where it gets a little bit tricky. What goes into 11? Remember, these are all our answers out in here, and these are all our answers out here. What goes into 11? Well, only 1 and 11 does, so I have to put 11 here. And 11 goes into 11 what? Once. So what is our actually prime factors? I'm going to go ahead and circle in red or in blue our prime factors. It's going to be 2 and 2 and 3 and 11. What about 1? Well, 1's not a prime number. It might seem like it is, but it's not. The prime factors are 2 and 2 and 3 and 11. And I kind of want to show you that. Let's go ahead and answer this real quick, and then we'll go ahead and check. What are the prime factors of 132? How can you tell from the ladder? Let's go with this. Let's do this again real quick. 2 goes into 66 33 times. 3 goes into 33 11 times. 11 goes into itself once. The prime factors are 2 times 2 times 3 times 11. It says, how can you tell from the ladder diagram? The numbers on the left. That's what happens. It's all these numbers on the left that are the prime factors. And then do you remember how to do this? It says E, write the prime factorization of 132 using exponents. Can I use exponents for any of these? Yeah, there are 2 2's. So that's 2 to the second power times 3 times 11. And we could check our answer here too. We probably should. Let's check our answer. Let's check it right here. 2 times 2 times 3 times 11. And what do we need it to be? 132. And it is. Alright, down here on the reflect, it's going to ask us to compare a factor tree and a ladder diagram, and I'm going to show you how to do that. It says complete a factor tree and a ladder diagram to find the prime factorization of 54. So basically I was going to do that up top with 132, but I'm going to do it with 54 here. So what we can do is we can put 54 in a ladder diagram, and we can put 54 on a tree diagram. I'll do the ladder diagram first since it's fresh in my mind, and then I'll do the factor tree, and we'll compare the prime factors. So what goes into 54? I always like to use 2 if I can. 54 is an even number. And 2 goes into 54. Well, it's going to be half of 54. That's going to be 27. So I put 27 here. And is 27 prime? It is not. It's divisible by 3. 3 goes into 27 9 times. Is 9 prime? It's not. It's divisible by 3. 3 goes into 9 3 times. Is 3 prime? Remember, we keep going until we get a quotient of 1, and this isn't 1 yet, so I divide by 3 again, and 3 goes into 3 once. That means I'm done. And then my prime factors are off to the left here. It's 2, 3, 3, and 3. Pay attention to those. Now we're going to do 54 as a factor tree. And I can do all the same exact math. Like, I can make all the numbers be exactly the same. It just looks different. Watch. What goes into 54? 2, and it goes in 27 times. Remember, we circle our primes, and we branch our composites. What goes into 27? 3 times 9 is 27. 3 is prime, 9's not. What goes into 9? 3 times 3. So check it out. The prime factors of 54 are 2, 3, 3, and 3. We can check that. 2 times 3 times 3 times 3 is 54. And we can see that in both. Here, I'll use my highlighter. You can see that 2, 3, 3, 3. We can see that in our ladder diagram, and you can see it in your in your factor tree. So you can get the same answer. Really, sometimes the directions will tell you to do one or the other, and then you have to follow those directions. But other times when you can just choose, you can choose whichever tool you like better. All right, let's check out number 7. If one person uses a ladder diagram and another uses a factor tree to write prime factorization, will they get the result? Explain. Yes, as long as they don't make any errors. It is worth pointing out that if you and your friend work on the same problem and you get different answers, it's either because, it's probably because there's a mistake. Yes, as long as they don't have any errors. Okay, great job. You're done with page 245.